Hi.
I got it.
Okay, so it worked. So the actual link did work.
Now it worked. Yeah.
Okay. So I was just like freaking out because there's people that I sent this link to, and I, we're
No,
fine now.
I agree. Yeah.
Yeah, it's just frustrating because it's like, I think what they do is they take away the license, and then because they can only purchase so many licenses, so they can only purchase so many like webinar licenses.
Okay.
And so it's this weird thing to keep costs down, from what I've learned, and that they can only give a certain amount of webinar licenses out versus like a meeting is just a meeting. With this, I don't know, it's just different. And I always have struggles with it. It's the last one, I was fine, and it like I didn't have any issues, but the other ones that I've had, I've always had an issue. So we're here.
Yes. And I apologize. It's because of me. So
No, it's okay. I had let me see, I have one more person that signed up like 4 minutes ago. And I was like, okay. So I have to send them the link real quick.
I'm gonna go use the restroom real quick, okay?
Okay. Could you just share your screen? You should have sharing abilities. If
Yeah.
you, perfect. And then what I'll do is we'll just go off, we'll go off video for a while, and then we'll just come back on at noon.
Okay.
And I wanted to double check because I know that I've never asked you, do I pronounce your name? I want to say Asli. Is it Asla?
It's Asli, like us.
Uh-huh.
Le.
So
But Le is hard. So La. You can say La. It's easy.
So Asla.
That's perfect.
Asla. Okay.
Asli. Yeah.
Asla. Okay. I'll just, my brain has to start to
Asli. Yeah.
to see that, but no, the us helps. So
Yeah.
okay. So yeah, so we'll just go off until noon, and I'll probably wait until like I'll say hello at 12, and then I'll wait a couple minutes after and start at about 12:03 or 4.
Sounds good. And I don't have a very long presentation. That's okay.
Okay.
It's like 28 slides, but I can talk.
Okay, well, we'll see. We have a couple students. We have a mixture of people here. So we'll see you in 10 minutes.
All right, sounds good.
Okay. Welcome, everyone. We're just going to wait a couple more minutes, maybe 2 to 3 minutes to see if some stragglers come in. They generally do. So we'll start at about 12:03, 04. Okay, I think it's a good time to get started. So welcome, everyone, and thank you so much for being here. And thank you, Dr. Aslan, for joining us. We really appreciate it, and hopefully we'll learn a little bit more about the intersection of climate change and public health. So before we get started, if you are a student and you need attendance verification, if you could put your Eagle ID in the chat, it'll just go to me, and so I can record that and make sure that you get that verification. So I want to introduce myself first. My name is Cami Sacco, and I am the Sustainability Coordinator for the Office of Leadership and Community Engagement. And I have asked Dr. Asli Aslan to join us today to discuss the intersection of climate change and public health. I'm sure some of us know the implications of the intersections, but many of us don't. And so she'll be here discussing that a little bit further today, and we'll open it up for questions after she's finished with her talk. So the introduction for Dr. Aslan is she is an associate professor of environmental health sciences and the director of the new Institute for Water and Health at Georgia Southern University. She has over 20 years of experience in health-related water microbiology. Her research program has been at the intersection of public health, aquatic ecology, and environmental engineering. Her research agenda includes microbial source tracking in water, drinking, recreational, and wastewater, the ecology of emerging pathogens in drinking water, antibiotic resistance and water reuse, the impact of extreme weather events on surface waters, and community action-based research. Her regional and international work among communities and decision makers aim to improve water safety while preventing the public from waterborne disease exposure. She's the co-founder of the APHA's Water and Health Committee and currently serves on the Scientific Advisory Board for the US EPA. Thank you, Dr. Aslan, for joining us, and take it away.
Good afternoon, everyone. Thank you for joining to this talk today. I hope you all had a great Thanksgiving with loved ones and slowly getting into the end of the semester. So today I want to take your focus a little bit more towards something else than courses and exams. And we're going to talk about how climate change and public health is related, especially in the context of water quality and health. So as you all know, our temperatures on the planet is increasing, partly because of the rising atmospheric carbon dioxide that is caused by excessive human activities, especially after the industrial era. Here on this graph, you're seeing the rising atmospheric carbon dioxide conditions since 1960s. And as you can see, the concentrations are reaching up to 420 moving into 2022. The carbon dioxide concentrations has a seasonal trend as the plants on the planet grow, starting from spring into the summer, the carbon dioxide concentrations normally decrease. But with the addition of the human activities, we're seeing more increase overall when you look at the long term, which also contributes to the greenhouse effect that happens on the planet, along with other chemicals that's created during industrial activities, such as nitrogen oxides and sulfur dioxides and all. Here on this graph, you're seeing the temperature increase over time since 1978 until today. One of the highest temperature that was ever recorded was actually in 2016, when we saw the carbon dioxide levels reach to 400 ppm in concentrations. Since 2016, the second one that was the highest ever recorded in human history was in 2020, not too far away, only a year ago. The greenhouse gases create several, global warming in different ways. Carbon dioxide is one of them, but like I said, methane or nitrous oxide are the other two that actually are still currently happening. And sometimes if you look at the graph on the right-hand side, the global warming potential of these two chemicals are even worse than what the carbon dioxide can do in greenhouse contribution. Methane can be coming from fossil fuel combustion or our food production, like our rice production, or waste dumps, or through the growth of our livestock, especially in concentrated animal farming operations. So humans impact global warming, yes. And what happens eventually is that as the temperatures go up, we're seeing more of the severe weather events, whether it is extremely dry periods and then followed by sudden precipitation, or storms and hurricanes that we're seeing more frequently. In the last 20 years, there has been a significant increase of these extreme weather events. This graph you're seeing here is actually just from October 2021, showing the monthly changes, monthly anomalies in temperatures on the surface of the planet. And as you can see, the more towards red, it means that some places are more hotter and warmer, and some places are more blue, which means much colder. The increasing temperatures, as you know, is also increasing the sea level rise. We're seeing more of that increase at the coastal areas that's impacting everyday life of people. We just saw a couple of weeks ago this higher tides and coastal flooding in Savannah region that flooded the roads and, the environment. Extreme weather, if we look at it from two different sides, one is the temperature and the other is the precipitation. You can see that in the United States, it's also a very heterogeneous. So some places are getting more warmer, whereas some of the places are seeing more of the precipitation. When you look at Georgia, you also see that the temperatures are much higher than the above. And also the precipitation is more observed compared to the baseline. The change in all these caused by climate change actually impacts the overall frequency of major disasters. So this is from NOAA showing that since 1980s, the climate and weather impacted disasters that cause more than $1 billion impact on the economy has been increased. And as you can see that some of the regions are experiencing some of these extreme weather events different than the other regions. When you look at Georgia and the southeast side of the United States, you're seeing that there is more of the severe local storms and also some level of flooding that's happening along with winter storms and tropical cyclones. How does that affect then human health, right? So humans are the part of the planet that is impacted by all these changes as well. Maybe they are the ones that's causing these changes, but they're also impacted. So rising sea temperatures and rising atmospheric temperatures are causing more of the extreme weather events, rising sea levels, and increasing also carbon dioxide levels. Well, starting with the carbon dioxide levels, never mind. What happens is, as the extreme heat or severe weather happens, then the consequences on the health is also significant. For example, when there is more of the heat on, especially in urban environment, then heat-related illnesses and death increases. Cardiovascular failure is more in the areas when there is urban heat islands are happening. Similar to that, when there is more severe weather, of course, that's related to severe weather, such as injuries and fatalities increase, but also that also impact mental health as well. So public health is also interested in that mental health component of the overall health. And we've seen at least a 30% increase in mental health related illnesses in areas where there is more frequent extreme weather events. Of course, all these changes impact air pollution. The more there is greenhouse effects, there is more pollution in the air, and that causes more severe chronic illnesses like asthma, especially in childhood asthma, and also cardiovascular diseases as well. Changing temperatures also changes the diversity of the animals and especially impacts the vector-borne diseases. We're seeing more of these diseases in places that we haven't seen before. So geographically, these diseases are also expanding as the temperatures warm. In terms of water quality, we're seeing more of the naturally occurring pathogens such as Vibrios, not just necessarily only cholera, but the types that causes gastrointestinal diseases or skin infections like vibriosis. We're seeing more of these impacts happening at a global level. Our water systems are impacted with our water quality issues. For example, we're seeing more of the harmful algal blooms occurring in the warmer temperatures, along with other pathogens like amoeba. It also impacts the availability for food resources. When you think about the amount of aquaculture that's happening overall and wild fisheries, we're talking about 540 million of the global population that depends on these kind of protein sources. And with the changes in the temperatures in these oceans and rivers, that actually impacts the biodiversity as well. The sea level warming also impacts the pH balances in the ocean. Today, the estimates are by 2100, year 2100, it will be increasing significantly. That will impact the marine life, especially within the ones that have shells and calcium carbonate. Increasing sea level rise and also the temperatures and more severe storms are impacting the flow of the rivers, which eventually also impact the quality of water in the area with the more input from the runoff as well. We're seeing, like I mentioned, more of these naturally occurring pathogens in areas where there is more increase in the temperatures. This graph you see here is a seasonal cases that's caused by vibriosis. And like you see here, that the higher the temperatures are, the cases of vibriosis increase significantly. Severe weather events might be either flooding, which we're seeing lately, 150 and 200 major floods per year. And that causes heavy rains to be bringing in more runoff and therefore more waterborne related issues, causing sometimes diseases. There was one study lately that's been published showing that whenever there's severe precipitation in Maryland, Baltimore, there are more cases related to salmonellosis, which is another gastrointestinal disease. So it really looks like whenever there is a change in the precipitation levels, it also impacts our water resources, which eventually impacts our health because our existing water treatment systems may not be ready to deal with these stressors immediately. Droughts also bring another level to this issue because during the drought periods, contaminants on the surface can actually be accumulated, and after prolonged droughts, whenever there's a rain, those contaminants will be washed out to the coastal environment or rivers or any other water bodies. So when I talk about our water environment, there are multiple layers to this, right? So we depend on water by looking at the drinking water, the wells, the reservoirs that provides us water resources eventually are vulnerable to these impacts of climate change. The drinking water treatment methods we have are a little bit outdated, right? We're using them since 1970s, and we're not really ready for emerging contaminants that are caused by climate change, such as increased level of harmful algal blooms, and the toxins that they're creating are not necessarily being removed through our drinking water systems. I'm going to talk about the household connections in a bit, but our built environment also are impacted by the effect of the climate change since they're already degrading and they're vulnerable. The wastewater systems around us, the more the people, the more the wastewater is created, right? So our sewer systems, our septic systems, they all contain a significant amount of contaminants and not necessarily always being treated to the level that the environment can carry. A great example for that is antibiotic resistance, because today we know that most of the wastewater treatment plants are also hotspots for antibiotic resistance going into the environment. Because most of our, again, treatment methods does not necessarily completely remove these resistant pathogens before they are released to the environment. Our recreational environments, our beaches, our swimmable and fishable areas defined by the Clean Water Act are also threatened by the impacts of climate change. More runoff coming from the lands and accumulation in the sediments that's been re-suspended back into the surface water. They're all a part of this impacts on public health, if you think about it from a larger perspective. Our shellfish growing areas, which many communities, like I mentioned, globally depend on that protein source for their livelihood, they are also impacted by all these land and climate-related impacts. This diagram really shows where we are standing as the US in terms of our water-related context. This is from Sustainable Development Goals, where you can see that our drinking water seems to be doing really well compared to the other countries. About 97% of our drinking water can consider to be safe based on the measures that we have that developed from 1970s. I'm not saying that these are completely accurate when you start thinking about emerging contaminants like PFAS, like nitrates and all. But when you look from fecal bacteria or these kind of classical traditional measures, then our drinking water seems to be safe. We've seen the issue with Flint, where the decaying infrastructure was impacting the household water systems. So those are not counted in this average here. What I would like you to look at is that water quality circle where it says 34%. So this is our surface water, this is our groundwater, this is our water sources that are already have been under severe threat by contaminants that humans themselves or naturally occurring contaminants are causing. So if you think about this in terms of climate change, then all these additional impacts that's going to be even more severe will be also impacting the water quality into the future. So we know that today, most of the coastal environment is under significant pressure by increased population. In fact, by 2030, we're experiencing much higher flow of people settling in a coastal environment. So more than 70% of the total global population will be residing in a coastal environment, which means that that's even more pressure on our aging water and wastewater infrastructure. There will be more demand for water, which many of these areas are not necessarily ready for. A good example would be the Savannah region right now, where majority of the population are dependent on groundwater, but then there is a red zone rule where you cannot actually drill more wells in this area. So incoming populations will need to be supported by additional water resources. Climate also impacts the frequency of waterborne diseases, like I mentioned earlier. So every time there is a change related to climate or weather extremes, then that also impacts the frequency of the waterborne diseases. The cumulative health impacts is kind of a newer concept where environmental health scientists hasn't fully have a grasp on yet. So most of these contaminants, when they are singled out, it's a little bit easier to predict what causes they can have on human health. But when it comes to combined impacts, so for example, in a groundwater source, if there is already naturally occurring arsenic, but then with the climate change, there is more water saturated, and eventually the nitrates coming from fertilizers from the surface starts impacting that groundwater, how those two chemicals have an impact on the humans who are using these waters without doing any treatment or maintenance of their water resources. So those are yet to be studied. I talked about rising sea levels already, but also think about this in the context of decaying infrastructure, right? So American Association of Engineers a couple of years ago graded United States distribution systems with a letter D, which is the worst letter is E, meaning that our infrastructure was already decaying. And how is that going to impact our water resources, especially at the household level? So that's a huge concern. And most of the time, all these issues come down to the point where people who are more vulnerable, whether through their health or their demography, who are underserved and who are lack of proper level of education. So these people are more even under the threat of these impacts. This diagram really shows how climate change and water quality are interrelated. Increasing sea level temperatures will increase the amounts of activities within the ocean, but also the contaminants coming from the land, like I mentioned, from farms, from livestock, from our wastewater treatment plants, from our leaking septics, from our asphalts in our urban environment during floods. They all bring in nutrients and these other chemicals that are sometimes not as high in concentrations in the ocean environment. And that enrichment triggers more of the algal blooms, which potentially might be toxic and then causing issues within the ocean biodiversity and also for people who are consuming those. Climate change, water quality also has an impact or direct relation with environmental justice, like I mentioned. Social vulnerability, the term, is often referred to the potential negative effects on communities caused by extreme stress on human health. So people with low income or lower educational degrees are known to be approximately 25% more likely to live in areas with the highest projected loss of labor hours just because of the temperature increases. So people also live in these areas show more than 15% of the asthma-related diseases as well. How is that going to be impacting water quality? That's still to be studied. This map is showing the distribution of social vulnerability throughout the United States that's been developed by CDC. When I looked at our area in Bullock County and Chatham County, these are the numbers, and the closer to 1, that means a higher social vulnerability. And as you can see, these numbers are high in our area as well. So coastal Georgia is a very interesting place if you're working on water quality and health like me, or you're just interested in environmental health, because this is one of the regions in the Southeast United States that is one of the fastest growing populations. In fact, by 2016, we're expecting that the population will be 1 million in coastal Georgia. The economic development is rely on paper, mining, manufacturing, tourism, fisheries, and the port of Savannah. Those are all related to water issues as well. Our water resources are mainly Floridian aquifers that we share with other states, neighboring states. But also we have major river basins that sometimes we tap on to use for water purposes as well. We have recreational beaches. We have 16 of them that are heavily populated, which creates economical boost as well. But also think it from the climate change impact and how these beaches are impacted by sea level rise and how that's going to be impacting overall economy. This is one of the highest poverty rate areas in the nation, with also 65% of the population lacking college degrees. There is not much equal opportunities for STEM education as well, and also environmental education. Some studies show that climate change and social vulnerability are directly related. This graph is actually showing how different aspects of social vulnerability, whether it's low income or minority populations or no high school diploma or 65 and older, may impact or have a direct relationship with parts of climate change impacts. So for example, if you look at the graph about minorities, you will see that the green bar is showing that inland flooding and property damage is inversely related to climate change impacts. But I'm going to show you something else today. So when we look at Georgia, coastal Georgia, we're also seeing that there are communities at the very front of the coastal environment that are actually experiencing the impact of climate change every day. One of these communities are the Gullah Geechee communities that live at the Sea Islands and coastal environment of Georgia. The projections for showing the Gullah Geechee communities and their locations where the sea level rise will increase over time shows that those are the people who are going to be most experiencing the impact of sea level rise and climate change. Which brings us to question, okay, how these communities will then be impacted by the change in the water that they are using in their everyday life. Most of these communities rely on groundwater, which is not many because, again, there are restrictions to drill more wells. And these wells may not be necessarily maintained in the long term as it should be. Or, you know, the pipelines may not have been changed over time. So that's creating more issues with the water quality. And how is that going to impact in the longer term is also a question. Water quality can be looked at different ways. One of it is the microbial contaminants. There are several types of pathogens that contribute to quality of water. The first thing that comes into mind is always E. coli, a gastrointestinal disease causing bacterium. But there are over 1,200 different pathogens that are within the waterborne disease category, from viruses to bacteria to protozoa, and not necessarily always only cause gastrointestinal diseases. Some of them cause respiratory illnesses like Legionella. So it's airborne, waterborne pathogen that lives on the sprays and water droplets. So when people shower, for example, or go to a greenhouse, the exposure is through inhalation of these pathogens. Some pathogens like Helicobacter, it's a bacterium. It's known as a carcinogenic bacterium because when it's located on the stomach cells, it will cause ulcers, and if not treated, those ulcers may become carcinogenic. So there are several types of these pathogens that may cause different types of health outcomes. Because most of these are also dependent on their environment, meaning the changes in the environment also impacts their presence in the environment. We're seeing more of these pathogens more frequently with the increased temperatures, especially like I mentioned with Vibrios, but also with Legionella. Legionella is a pathogen that likes to live in warmer temperatures. The warmer the temperature is, the better. So they can actually thrive in environments for up to 45 Celsius degrees, which is a concern in the context of global warming as well. These are some of the other exposure pathways and certain pathogens and how climate is related to that. I'm not going to go too much in detail to that. I already mentioned most of it, but again, just to reiterate that most of these pathogens are not necessarily being removed before humans are exposed to them. So there's still much to do from an engineering side, from a public health side, from a policy side as well. The water environment also is very vulnerable, like I said, to flooding. This is a picture from, I think it's Hurricane Florence in 2018. Here you see that smear of manure that's coming out of the livestock farms in North Carolina, which eventually also ends up in Georgia as well. And we've seen similar things when, severe weather events happened in our water resources and water environment. One study we did with Dr. Risa Cohen from biology, that we showed that the antibiotic resistant bacteria in even reference stations that we had, we thought that we wouldn't have, actually ended up showing high levels of bacteria after Hurricane Matthew, 2 weeks after the hurricane. So what I'm trying to say here is that when these events happen, they don't necessarily go away immediately with the water flow. They stay and they persist. And that the more they persist, the more there's a risk of people being exposed to them. That's where the flooding and water environment becomes an issue in the context of climate change. Like I said, our water environment means also our household level, right? When you open the tap, the water that comes out of that tap really defines your health in a way when you drink that. This graph is showing the number of Legionella cases over time. There is an increasing trend in detection of these Legionella cases at the household level as well. Why is this happening? Do we have better detection methods? Are we paying more attention to these emerging diseases? Maybe, but also there is also the understanding that we are also experiencing more of that warmer temperatures that promotes the growth of these pathogens. And more importantly, we're not doing a good job in maintaining our distribution systems. So this diagram or drawing on the left really shows you how a pipeline looks if you do a cross-sectional cut on it. The biofilms, meaning the extracellular products of living organisms in the pipelines, eventually create this shielding environment for all these living creatures in the pipelines that protects them from disinfection, especially chlorination that we always use for treating our water systems. So because chlorine cannot penetrate through these biofilms, the bacteria or protozoa or whatever pathogen could technically be there will not be killed off by these disinfectants and eventually ends up in the tap. So again, everything is so connected in terms of the infrastructure and how climate and how the pathogens persist in the environment becomes an issue, especially when we're experiencing more saturated soils with more precipitation, more flooding, sunny day flooding, all of these, if these pipelines are not well maintained through the leaks, additional contaminants will enter to our water systems. So what should we do? The most important thing in public health, we say, is work with the communities, community buy-in. That's where comes the community-based participatory research. One of our, now he's a doctoral student, Edward Othero, he conducted a study in the middle of COVID and tried to ask the questions to the residents of Evans County about how they maintain their well water and how they treat their well water or even test their well water. The reason why he was asking these questions is because in the United States, 1 in every 6 households, people are dependent on private wells. These private wells are not necessarily protected by the Safe Drinking Water Act because they only serve to the individuals. So individuals are responsible for testing, treating, and maintaining their private wells before they consume that water. So the questions he asked show that only 34% of the participants have ever tested their water for contaminants. And most of these tests were conducted over 10 years ago. In terms of water treatment, only 25% treated their water ever with chlorine tablet or any type. That includes also refrigeration filters. So some people have that those filters on their refrigerators. That number is in here, so not necessarily chlorine always. And for well maintenance, only 16% have a regular maintenance for their systems, looking at if there are any, leakages or any flushing happened. So this is a regular day, just a snapshot of how it looks like in our communities from just one local study. This really shows how important it is to reach out to the communities about potential threats that they may actually see moving forward into the future and how climate change may also impact these as well. Oh, in that study, I forgot to mention, he also provided some educational materials along with some on-tap filter systems to be installed on their kitchens. Only 22% of that group actually use those filters. And they said that, oh, I'm gonna keep using this because the water tastes better. I like it, it's easy to use. So those kind of interventions may actually help for people to have that community buy-in when it comes to access to safe water, but there is so much to be done. So this is my last slide. So like I said, everything is connected when you talk about water environment in the context of climate change. Our drinking water systems, our wastewater systems, recreational areas, or our food systems are all dependent on the quality of water we have, and how that is impacted by climate change will be the next question that we need to have to address. This needs multidisciplinary action, not just as a public health and even though public health is itself within itself is an interdisciplinary discipline, we still need that multidisciplinary approach. And this is what we're trying to do with our new Institute for Water and Health, bringing in experts and people who are working on the water research area that will eventually work with alongside with our communities in the region to provide better solutions. With that, I'm going to stop and look for questions. Thank you for listening.
Thank you so much, Dr. Aslan. So we have one question. If we have other questions, I had written a couple down as well. So the first question is from Santiago, and he said, could you explain the relation between mental health and severe weather?
So that's a great question. This is a new area of research. Actually, we're seeing more people with the climate change to be relocating, and that stress of relocation for people who have never been, moved to another place and had to leave everything they have owned their lives and start a new life in a new place, actually creates a significant amount of mental health issues. So is that an answer to your question?
Yeah, I think so. I think, yeah, he had just wondered what the larger connection would be. And I think that, adding on to that, we had done another lunch and learn maybe it was about 6 weeks ago, that actually talked about climate anxiety a little bit, and just people being, feeling somewhat helpless in terms of fighting climate change. And so that also could contribute to, the effects of mental health that people feel individually. So, and we have that's up on our YouTube if you're interested in looking at that too. So you talked about Legionella. What is that? I mean, I feel
Okay, so Legionella is a bacterium that lives naturally in our water systems. It's there. It's nothing related to our septic systems or anything related to human activities. It's there. What happens is it grows much faster and thrives in warmer temperatures. It also is protected from any type of stressors, including our own disinfectants. So the more we add chlorine, we don't necessarily kill off Legionella from the environment. The reason for that is, again, our distribution systems. So when Legionella enter to our distribution systems at the household level, if those pipelines, let's say, are already clogged and they have biofilms in that, Legionella can actually hide under these and then not necessarily be killed by disinfectants. So that's one thing. And then again, the temperature increases are also showing higher levels of Legionella in our systems. We did one study looking at the hot water tanks in Georgia and see how these Legionella bacteria grow. We've seen that people tend to decrease the temperature of their hot water tanks to save energy, but those tanks actually show higher levels of these airborne, waterborne pathogen because they thrive in these temperatures. So yeah. It is a pathogen that is waterborne, airborne. It can be traveling through the sprays and aerosols, and it is mostly impacting human health through inhalation. So when people inhale these aerosols, it resides on the lungs and then creates a disease called Legionnaire disease, very similar to pneumonia. Sometimes doctors wrongly treat this disease for pneumonia with wrong antibiotics, and that actually increases the mortality rates, especially among people over the age of 50.
Gotcha. So is it common that people will get that disease, or it's still fairly uncommon, or it's increasing because of?
The case numbers are increasing overall throughout the world. Europe have recognized this a couple decades ago, and they have been doing a lot of community-related research to fix their distribution systems and to try to fight with this. But in the US, hasn't been an issue or recognized as an issue until 2016, when there is the National Academy of Science brought together a group of experts to start addressing this issue, because they started to see, CDC started to see an increase in cases over time. And that's how it started. So it's relatively new for our country.
Okay. Another question that you had talked about the red zone rule, and I'm a little curious more about what that is.
So in Georgia, we have areas that are called red zone areas, where we're not supposed to be drilling more wells, because if we tap into that groundwater more with an uncontrolled way, if everybody tries to extract more water, like I said, this Floridian aquifer that we're sitting on is actually shared by other states as well. So for the conservation of that water source, plus the more you extract from that groundwater, that means that at the coastal area, with the sea level rise, there will be more salt intrusion into that groundwater. That will be even harder to treat. It won't be just chlorination at this point. You need to remove that salt first before people can even drink it. So that all impacts both the water quality and the quantity or availability. So red zone areas allows that control for not extracting more of that groundwater. But that doesn't solve our problem with increasing population, again, because how are we going to meet the demand? So that means that we're going to be relying more on either mixture of surface water with groundwater, or maybe more modern methods like reuse, where we start using reused water, which is treated water that is available for drinking.
Gotcha. Santiago had another question. He said, as dumb as it sounds, is there any artificial way of creating water, either suitable or not for drinking? If so, how? If not, what would it take us to be able to do so?
It's reuse, right? So we can, well, Singapore, the whole country is on 100% reused water. So they literally treat their own wastewater to drink it. So there are technologies, there are methodologies. It's all about that investment. Most of our drinking water treatment plants here in the United States have been established in 1970s or even 50s. So changing those technologies, upgrading those treatment plants so that they can also have this more greener reuse, sustainable methods, it's going to take time, and more importantly, dedication for investment.
Gotcha.
There is also desalination that, many other places are doing, which is deemed to be expensive.
Yeah, I think still at that point, it's not economical to move forward with desalination. Do you think that is part of the future, though?
I think the future will be all about reuse. We gotta, it's because it's not only providing us water resources, but it's also helping us to remove the contaminants from our water resources, right? Mm-hmm. So having that modernized treatment systems will really have that sustainable approach.
Gotcha. Okay, I think those, I guess I had one other very local question, because I'm assuming I know there's some students on the call. So does Statesboro get their water from the Floridian aquifer? And do you know?
We are. So we're on groundwater. It's the Floridian aquifer. I take my water quality students to the treatment plant for a site visit every semester, but private citizens can actually schedule a tour and go and see how they're treating our water, both our wastewater and drinking water. But in a nutshell, our drinking water is extracted from the groundwater, it's filtered, and then it's chlorinated and then distributed at the city of Statesboro. The more you're at the outer skirts of Statesboro, then you're most likely on a community well, which means that in your cul-de-sac, or that you have this community well that serves that whole community in that environment, which again uses the exact same treatment method, which is chlorination.
Gotcha. And is
And
it the same?
we don't use fluoride in our water systems most of
Okay.
the time.
And is that the same in Savannah? I know it's also from the aquifer, but there's then a separate treatment center?
There is also mixture of surface water in some areas.
Mhm.
But yes, in general, the treatment for groundwater is very basic.
All right. Well, any other last minute questions? This was great. I felt like I learned a little bit more about water specifically and how it does impact human health. It's so broad. Public health also is so broad too, like thinking about how climate change and public health are related. So you got it.
Very interconnected.
Yeah, absolutely. All right. Well, if there aren't any last minute questions, students, if you'll put your Eagle IDs in the chat, and I'll make sure you get attendance verification. And thank you again for your time, Dr. Aslan, and have a great day, everyone.
Thank you. Happy semester, everyone.
Yes. Good luck with the rest of the semester.
Good luck.
Bye.